So where we were? We were at quotient rule, okay? So continue this. If we have some numerator and denominator, then what you have to do to differentiate this is that you have to firstly square the denominator, okay? Denominator remains as it is, then you have to differentiate numerator minus numerator as it is, and you have to differentiate denominator, alright? Like this. If you have to differentiate this, okay? So what you have to do is squaring the denominator, keep denominator constant, and take the differentiate of numerator minus what? Take numerator as it is and do the differentiation of denominator. So what you get is denominator differentiation of x is 1, so we get sin x minus x. Differentiation of sin x is cos x. You can much more simplify this by distributing denominator to both the numerator, and here you go, you get the answer. That is, sin x is cancelled out with sin x. This 1 upon sin is cosec x minus x cos upon sin is cot. As you know, tan is sin upon cos, tan theta is sin upon cos theta. So cos upon sin is cot, as cot is inversely proportional to tan, and 1 upon sin becomes cosec x. This is our answer in simplified form. Okay, I hope you understand. Now, thirdly, our third formula is chain rule. What is this? What the chain rule is really about is that let us take an example. This is x square. Okay, x square e raised to power x square. Okay, this is our example, and we have to differentiate it. Then what we have to do is differentiate with respect to x. We know about the formula. Differentiation of e raised to power x remains e raised to power x. E is exponential here. Okay, but here e has raised to power as x square. So what do we do now? We have to take or assume x square as single x. In chain rule, we assume that what the formula is, you have to convert it in that form. Okay, so e raised to power x becomes e raised to power x. You assume that x is really x square, actually x square. So e raised to power x, we know the formula for e raised to power x for differentiation is e raised to power x. Now the variable which you assume x, you have to multiply that differentiation with the differentiation of that which you have assumed. Okay, means e raised to power x as it is, then x differentiation of this, differentiation of our new x, this becomes 2x. So okay, so we get answer like this. Alright, let us take one more example. One more example is that you have to take